Now that you know how to label these triangles, what we need to do now is be able to use our labels to write a trig ratio. Now, there's a lot of information that's going to go on this sheet, so you want to make sure that you are paying attention and writing everything down. The first thing you need to know is that whatever letter comes after the sine, cosine, or tangent function, that's the angle theta that they're referring to. So what we're going to do for the top 3 questions in number 1 is we're going to put theta in the letter K spot. Letter K is up here. So we can put our little theta mark. Now theta looks like a circle with a line through it. And this is our reference point for how we're going to label. So once we have our theta labeled, based on the fact that they use K, that's where I put my theta. Okay, and then what we're going to do is we're going to label the hypotenuse, which is across from the right angle, our adjacent, which is between the theta and the right angle, so this is the adjacent side, and the hypotenuse and the adjacent only leave left the opposite, and the opposite is across from the theta, which is down here. So we just took what we did in the last slide and we applied it here. Again, with the only new thing right now being that this capital letter represents the angle that is our theta angle, which is K. All right, so that's all labeled. The other thing is that we are missing a side length. We have an adjacent and we have an opposite, but we're missing the hypotenuse. And this is where we got to go back in time and you need to think about how do you solve a right triangle for a missing side. And one of the ways to do that is using Pythagorean theorem. So over here on the side, what I'm going to do is I'm going to write down my Pythagorean theorem, a squared plus b squared equals c squared. This is to find a missing side. When you know 2 sides, this is how you do it for a right triangle, okay? But here's the kicker. The hypotenuse has to be in the C position. Has to be. Okay? The other 2 sides, the opposite and adjacent, can go in the A and B spot in whichever order, but the hypotenuse must be in the C position because it's the largest. So as I'm putting this information in, the A value could be 8, and the B value could be 15, but I don't know the hypotenuse. The hypotenuse is the one that's missing, and I need that one. So I leave that my variable. I'm going to pull out a calculator and make things a little easier for me. I do need you to make sure that you remember how to do this because we're solving for the hypotenuse that has to go in the C position. 8 squared is 64, and 15 squared is 225. So I'm going to add those up. And that gives me 289. And remember to get rid of a square term, you have to square root. And the square root of 289 is 17. So this hypotenuse value is going to be 17. Now that I have all 3 lengths, I can answer these 3 questions. Okay, so I have my 3 lengths. I've got them all labeled. Now I just have to remember my SOHCAHTOA. So we just did some Pythagorean theorem to find the missing side. We labeled it based on where our theta was that they give us, which was capital K. And now I need to do SOHCAHTOA. And the key thing for SOHCAHTOA is making sure that you spell it correctly. I know that sounds silly, but if you don't spell it right, you're not going to do it right. It's SOHCAHTOA. SOHCAHTOA. And so represents a sine function. And the sine function is going to be opposite over hypotenuse. In which case over here, my opposite side is 15. And my hypotenuse is 17. See, when I label it, it's so easy to find. Ka represents our cosine. I'll do this. And so cosine is adjacent over hypotenuse. And our adjacent side is 8. And our hypotenuse is 17. And then, of course, TOA is tangent. And so I need opposite over adjacent. And my opposite is 15, and my adjacent is 8. And that's all they want us to do when we're writing a ratio. A ratio is just a fraction of a side to another side. In this case, whatever the function is, here's my so ka toa. That's kind of how it works. This would be you writing the ratio, and that's all you would have to do for number 1, ABC. Now, what they did for D, E, and F is a little interesting. What they did was they actually changed our theta representation. So what I do to keep things all good, I just draw the diagram again. It takes me 30 seconds to keep everything neat and orderly. And I can put my 8 in here. I can put my 15 here. I already saw for this side of 17. I already know that this now is my theta. The H, capital H, is now my theta. So I'm going to put my theta down here as opposed to up top. So because my theta is here, that helps me to remember that I need to change my opposite adjacent because they're not going to be in the same position. Hypotenuse stays exactly where it's supposed to across from the right angle because the right angle is fixed. That stays where it is. But when you take your adjacent and you look between your theta and your right angle, this is where your adjacent side is now. And of course, opposite is across from your theta, so that is now 8. So as we do SOHCAHTOA, again, we have opposite over hypotenuse. For this one is now 8 over 17. Cosine is ka, that's adjacent over hypotenuse, and that is going to be 15 over 17. And then you have t for toa, tangent, and that's opposite over adjacent, and that's 8 over 15. So take a look at the relationship between these. These are both the same triangle. I just redrew it so that based on where your theta is, that's how you get your labels. So you've got to put your theta in based on your your uppercase letter here that represents your angle, and then you label, okay? So what I'm going to do is I'm going to come down here and I'm going to walk you through this one. And the reason why I want to walk you through this one, not so much for this, because I think you'll get this, it's more here. And the reason for that is because we're still missing a side. In our number 2 example, the side that we're missing is not a hypotenuse. It is not. It is a side length, and depending on your theta, is either going to be an opposite or an adjacent. So when we go to find a missing side and we're doing Pythagorean theorem, a squared plus b squared equals c squared, the c, remember, has to be the hypotenuse. And since that one is fixed, I know the hypotenuse is going to be 20 no matter what. No matter what. And that has to go in the c position. Some people just put the 2 numbers in, and that's not correct. You have to make sure you put the hypotenuse into the C position always. And then the other ones are 16 and are unknown, and it doesn't matter what order those go in, but the hypotenuse has to go in here. So I'm going to do 16 squared plus b squared. Now, if you have a squared plus 16 squared, that's fine, because you're going to end up finding it anyway. Then you've got to square all the terms. So 16 squared, I think, is 256. And 20 squared is 400. Remember, you're squaring those, not doubling them. And then to get this by itself, you have to subtract your 256. So this is a little bit more math involved in solving for a missing side when it's not a hypotenuse. Using the calculator quick to double check my math, and I get b squared equals 144. Don't forget you have to take the square root to get that square term out of there to get b alone. And that means the square root of 144 is 12. So this is side AC. So no matter where my theta is, 12 has to be the length of side AC. And I use Pythagorean theorem to get there. Now we can go ahead and look at where theta belongs in this case. For our first one, they want theta at angle B. So I'm going to put theta up top. And we're going to label these based on where our theta is. Now, our hypotenuse is already 20. That's standard. That's fixed. But my adjacent is between my theta angle and my right angle. So adjacent goes here. My opposite is across from my theta angle. That's down here. So now that this is all labeled, I can go ahead and bang these three out. So opposite over hypotenuse. This is my SOH. S-O-H. So opposite is 12. Hypotenuse is 20. And of course, you should reduce that. 12/20ths. Common factor would be 4. So you would end up with 3 over 5. Cosine B. Cosine is ca. So I need adjacent over hypotenuse. That's 16 over 20. Divide top and bottom by 4, and you get 4/5. And then you got tangent, which is your TOA. And that's opposite over adjacent. And that's 12 over 16. Divide by 4, and you get 3/4. Okay, so this represents my B's as my theta. Again, I don't know if you have to do this or if you don't like to. I certainly need to keep myself organized. I'm going to take 30 seconds and redraw this diagram down here. It doesn't even have to be so big. It's more just making sure that I have the labels in the right spot. See, that wasn't bad. And then, of course, my hypotenuse is still 20. The hypotenuse will stay put. So it's always across from the right angle, except now we want our theta changed to C, angle C. So I'm going to put my theta spot here because that's the capital letter that follows the function. And now I know that I'm going from here. So my adjacent is now on the floor. And my opposite across from my theta is 16. Now I can do my SOHCAHTOA. Opposite over hypotenuse, I'm looking at 16 over 20, which of course is 4/5. Ka, adjacent over hypotenuse, that's going to give me 12 over 20, and that's 3/5. And opposite over adjacent for TOA is 16 over 12. And that's going to give me 4/3. And there you go. That's how you write your ratios. Again, we did a little bit of work here. The first thing we did was we needed to make sure that we got all three sides. We did Pythagorean theorem to find our third side. Once we did that, we looked at the capital letter. That was our theta. We marked our diagram with our theta. Then we labeled. After you label, then you can write your SOHCAHTOA down, write what your ratios are, and then make sure you reduce them.